Hi everyone, this is Kshitij Patel. Welcome to my quick guide on exploring trade data and CO2 emissions data using R. Today we will be diving into some awesome R libraries that make data analysis and data visualization a breeze. We will fetch the data from IMF itself, and a neat way to do it is using imf.data package. Why is this important? It's because if you want to fetch the data from IMF website, you will not require any kind of API key, which is an interesting thing because nobody likes to pay for every API request that you give. So it will give you the access to this data for free. And another one is through the IMF International Monetary Fund's climate change dashboard. I would be downloading one of the dataset from here. So this is about the CO2 emission dataset. So we will be plotting and understanding and analyzing certain facts along the way. So let's get started. So starting with this dataset, direction of trade dataset, from here we will be retrieving a time series of United Kingdom and its trade volumes. So using this package called as TS Studio, which is an interesting package for manipulation of time series data. We would be just plotting a simple time series graph. While you can see that this graph is good, but it ain't that neat. So how can we do better? We'll look ahead. I'll provide you with some more libraries which are richer. So right here we have done another plot, which is a seasonality plot. What can we understand from here? We can understand that during the month of March there is a high trade volume, and during the month of October there is lower trade. And then the trade again rises up to December, which kind of makes sense because December is when we have Christmas and there's a lot of consumer activities. So now this digraph library in R helps you to build more complex graphs like this, which minimal amount of code, which is pretty interesting because they also allow you to have a slide bar, which seamlessly moves around to even a granular level, and you don't even have to code for all of this. It's all included in this package digraph. So it's a very neat way of showing your projections. Next, so this was cool, but what if we want to have a combination of economies which we want to compare to? So using this package again, we can see that on the top right, there's a legend that continuously changes dynamically, which is amazing again for any kind of comparison that you want to do. And these are some more graphs you can go through. I'll be providing the link in description. Next on, we will be trying to fit the ARIMA model. The way we are going to do is using this forecast library, which is very useful for providing any kind of forecasting that we want to do to any kind of time series. So using this forecast library over here, we can see that I have predicted a forecast for UK, for US, and for Canada. And then moving on to the next data set. This data set, again, I have downloaded from IMF, which I've showed you before. So we'll go through this data set very quickly. Over here, we have a column called as country, and then we have this ISO3 code name, and then we have carbon emissions from 2005 to 2018. We won't be requiring all of the data, so I will be basically aggregating this on country and ISO3 level. And basically, we don't need this granular data, so we will be just taking a sum of all the departments or sectors. So that's all this code. And over here, I've plotted this code using ggplot and plotly. And you can zoom in over here and you can go through any countries that you want, Italy, France, Germany. It's very interactive and very easy to use. So this is a very powerful tool at your disposal. By the way, an important part is the way I have done it is using R natural earth, which is very useful and which is very important in mapping this graph. Just keep in mind this library. Next one, we will go to animation. So we will make a time lapse of these changes that happen over time. For this, we need gganimate and GIFs key library. So if you are in some presentation and you want to show a time lapse, this is an amazing way to do it. So these all are countries. That is how it changes over time. Next on to we have done is we have used the WDI, that is World Bank data set, and we have merged it with our data set to get a per capita emission of CO2. So in per capita, you will see that the countries in Europe are not so much. The countries in Europe have a higher higher per capita emission as compared to Mexico. And then what I've done is I've applied a k-means clustering to cluster these two groups. And with this elbow curve that I have plotted, we can see that it will be broadly classified in two groups. And these two groups are logically make sense. The high polluting nations, that is Mexico, and some European nations, which are industrialized as compared to the other economies. And this is a correlation plot between CO2 emission and GDP over time. So over here, you can understand, analyze certain things that how the correlation goes down. It could mean a lot of things, but by the looks of it, what we are seeing is we are transitioning from heavy CO2 related activities to clean energy. So that is why the GDP and CO2 are getting divergent. So now GDP is no longer connected to the CO2 emissions, which shows a good trend. So that's it for today's video. And you guys will have all the resources. I'll just upload a zip file in the drive, which you can unzip and use it, and all the other links that is required. For example, if you require any documentation regarding the APIs that I've used, I'm providing all of these links. So yeah, if you have any doubts, you can put it in the comment section. Yep. Thank you.